Today we'll discuss ISI's BStat BMath 2015 paper, and this paper again has some wonderful questions. And the first question is, let C denote the set of complex numbers and S is Z bar equals Z square. Then S has how many elements? So what we'll do is we'll let Z as X plus iota Y. So let Z equals X plus iota Y. So we can write X minus iota Y, and it'll be equal to x square minus y square plus 2xy iota. Now we'll compare real and imaginary parts. We can write x equals x square minus y square, and then minus y equals 2xy. Now we'll solve the second part. We'll get two conditions. Either y is 0 or the value of x is minus 1 by 2. Now if we put y as 0 in this equation, we'll get x square minus x equals 0. We'll get either x as 0 or x as 1. So we get two solutions, that is 0 plus 0 iota, z equals 0, and then 1 plus 0 iota, that is when the value of z is 1. So we have two solutions when the value of y is 0. Now if we take x as minus half, we can write this as minus half equals 1 by 4 minus y square, that is the value of y square is 3 by 4, value of y is plus or minus root 3 by 2. So we have two more solutions, and which are minus 1 by 2 plus minus root 3 iota upon 2. So this set S has 4 elements, and that's your option B. Now the second question is straightforward question. It says number of 1-1 functions from a set with 3 elements. So here we have a set with 3 elements, say A1, A2 and A3, to a set with 6 elements, say B1, B2 and B6. Now here we need to find number of 1-1 functions from this set A to set B. Now for each of these 3 elements, we need to find 3 distinct elements in B, which can be done in 6C3 ways. Now once we have 3 elements, we can map all these 3 elements in A with elements in B in factorial 3 ways, which is 20 into 6, that is 120 ways. So total number of such functions will be 120, and that's your option C. Now question number 3 again is very simple. It says two sides of a triangle are of length 2 centimeter and 3 centimeter. Now let the angle between these two sides is theta. Then we know that area of this triangle is given by half AB sine C. So it will be 1 by 2 into 2 into 3 into sine theta. We can cancel this 2 with 2. Now the maximum value of sine theta is 1. So the maximum value of this area, it will be simply 3 square units, and that's your option C. Now here the question is number of factors of 2 to the power 15 into 3 to the power 10 into 5 to the power 6, which are either perfect squares or perfect cubes. Now we know that all the factors of this number, they can be expressed as 2 to the power 0 plus 2 to the power 1, 2 square up to 2 to the power 15 into 3 to the power 0 plus 3 to the power 1 up to 3 to the power 10, and then 5 to the power 0 plus 5 to the power 1 up to 5 to the power 6. Now here we have 16 elements, here we have 11 elements, and here we have 7 elements. Now first we'll find number of factors which are perfect squares. Now for perfect squares, we need even powers for these numbers. Now even powers for 2 will be 2 to the power 0, 2 square 2 to the power 4 up to 2 to the power 14. So it will be 7 and 1, 8. So there will be 8 such values, and then for 3 it will be 3 to the power 0, 3 to the power 2 up to 3 to the power 10. So we have 6 such values, and then for 5 it will be 5 to the power 0, 5 square 5 to the power 4 and 5 to the power 6, that is 4 values. So it will be 8 into 6 into 4, that is 192 numbers. So there will be 192 numbers which are perfect squares. Now for perfect cubes, we must have power of 3. Now how many powers of 3 are possible for 2? For 2, the powers of 3 that we can have is 2 to the power 0, 2 to the power 3, 2 to the power 6, 9, 12 and 15. So altogether we have 6 such numbers, and then for 3 it will be 3 to the power 0, 3 cube, 3 to the power 6, 3 to the power 9. There is 4 such values, And then for 5, it will be 5 to the power 0, 5 to the power 3 and 5 to the power 6. There is 3 values. So it will be 6 into 4 into 3. And that is 72. So we have 192 perfect squares and then we have 72 perfect cubes. Now we need to subtract all those numbers which are both perfect squares as well as perfect cubes because they are counted twice. So we need to remove all those numbers which are perfect squares and perfect cubes. For that we must have powers of 6. So for 2 it will be 2 to the power 0, 2 to the power 6, 2 to the power 12. For 3 it will be 3 to the power 0, 3 to the power 6, and then for 5 will be 5 to the power 0 and 5 to the power 6. So we have 3 such numbers, then 2 here and then 2 here. So it will be 12. So total number of factors which are either perfect squares or perfect cube will be 192 plus 72 minus 12, and that comes out to be 252, and that's your option D. Now question number 5 is the minimum value of this function x square plus 4x plus 4 upon x plus 1 upon x square where x is greater than 0 is. Now if we take x square plus 1 upon x square, we know that am is always greater than or equal to gm. That means x square plus 1 upon x square, it is always greater than or equal to 2, and we'll have this equality sign when the value of x is either plus 1 or minus 1. That is when x square is equal to 1 upon x square. Now for 4x and 4 upon x, again if we take arithmetic mean, it will be greater than or equal to its geometric mean, which is 4. So from here we can say 4x plus 4 upon x, it is greater than or equal to 8. Now again we'll get this equality sign when the value of x is plus or minus 1. Now since x is greater than 0, both these functions, they'll have their minimum value when the value of x is 1. Now we'll add these two expressions. We'll get x square plus 1 upon x square plus 4x plus 4 upon x, and it will be greater than or equal to 10. So we'll get fx is always greater than or equal to 10. So the minimum value of this function will be 10, and that's your option C. Now question number 6 is the minimum area of the triangle formed by any tangent to this ellipse and the coordinate axis is. Now we take any point on this ellipse which is a cos theta and b sin theta. We know that equation of tangent is given by t equals 0, which in this case will be x cos theta by a plus y sin theta by b, and it is equal to 1. Now if we look at intercepts, intercepts will be a upon cos theta comma 0 and 0 comma b upon sin theta. Now area of this triangle formed by coordinate axis and this tangent, it will be given by 1 by 2 ab upon sin theta into cos theta. So it will be ab upon sin 2 theta. Now this area will be minimum when the value of sin 2 theta is maximum, and the maximum value of sin 2 theta is 1. So minimum value of this area will be simply AB, and we'll get this minimum value when sin 2 theta, it is 1. That is when the value of theta is pi by 4. So answer to this question is option B. Now question number 7 is the angle between the hyperbolas at their point of intersection is. Now let the point of intersection be x1 and y1. Now we'll differentiate this first curve. We'll get x y dash plus y equals 0. We'll get y dash as minus y1 upon x1. So m1 is minus y1 upon x1. Now for the second curve, it will differentiate it. We'll get 2x minus 2y into y dash equals 0. That is y dash is x1 upon y1. So we'll get m2 as x1 upon y1. Now if we multiply m1 with m2, we'll get m1 into m2 as minus 1. That means angle between these two curves is simply pi by 2, and that's your option D. Now question number 8 says the population of a city doubles in 50 years. Now in how many years will it triple under the assumption that rate of increase is proportional to number of inhabitants. So that means rate of increase, that is dn by dt, it is proportional to n. So we can write this as dn by dt, it is equal to some lambda n, that is dn upon n is equal to lambda dt. Now we'll integrate this. We'll write log n equals lambda t plus c. Now when t is 0, let initial population be n naught. We'll get this c as log n naught. Then we'll get log n upon n naught will be equal to lambda t. Now it says the population of the city doubles in 50 years. That means when the value of t is 50, value of n is 2n naught. So we'll get log 2 equals lambda into 50. So value of lambda is log 2 by 50. So we can write this expression as log n upon n naught log 2 upon 50 into t. Now we need to find the time when the population triples. So that means here we need to put the value of n as 3n naught. So we'll get this as log 3 and it will be equal to log 2 upon 50 into t. So we can write this t as 50 log 3 upon log 2, and using base changing property we can write this as 50 into log 3 base 2. And that's your option A. Now question number 9 is, we are given some functions f1, f2 and fn, and we say these polynomials are linearly dependent if there exist real numbers c1, c2 and cn, not all 0, such that c1 f1 plus c2 f2 up to cn fn is 0 for all real numbers x. Then which of the following is a linearly dependent set? Now if we look at this expression, we know that it is linearly independent, because if I put ax plus bx square plus cx cube equals 0, and if it is an identity in x, then clearly I'll get a equals 0, b equals 0 and c equals 0. So all the constants in this case will be 0. So this set of numbers will be linearly independent. Here also, when I see this x, x square and x cube, they must be linearly independent. Now we are left with two options, b and d. So first we'll check this b. So we'll write a x square minus x plus b into 2x plus c x square plus 3x equals 0. We'll write this as a plus c x square plus minus a plus 2b plus 3c x equals 0. We'll get this condition that a plus c is 0 and minus a plus 2b plus 3c is 0. Now the value of a is minus c. Now we'll put c as minus a. We'll get 2b equals 4a. Value of b is 2a. So in this case, it is possible to have non-zero values of a, b and c. That means these three functions, they must be linearly dependent. So the answer to this question is option B. If you want, you can check this fourth option also. We can write this as a x square minus 1, b 2x plus 5 and c x square plus 1. Now we can write this as a plus cx square plus 2bx minus a plus 5b plus c equals 0. Now we'll get a plus c equals 0. We'll get b equals 0 and minus a plus 5b plus c equals 0. Now if we put b as 0 here, we'll end up getting a equals 0 and c equals 0. That means this fourth set of function is also linearly independent. So the only set which is linearly dependent is this option B. Now question number 10 says, a set of numbers S is said to be multiplicatively closed if this product A into B belongs to S whenever A and B, they both belong to this set S. Now considering I as under root of minus 1 and omega b non-real cube root of unity, we need to find whether S1 and S2, they are multiplicatively closed or not. Now if we consider two elements in S1, say A plus B iota and A dash plus B dash iota, where A dash, B and B dash, they are all integers, and if we multiply them, we'll get A plus B iota into a dash plus b dash iota, it'll be a dash minus b dash plus ab dash plus a dash b iota. Now since all these four numbers, they are integers, then a dash minus b dash, it is also an integer, and in the same way ab dash plus a dash b is also an integer. That means their product, it belongs to S1. So clearly S1 is multiplicatively closed. Now what about S2? Now again we'll consider two numbers in S2, say a plus b omega and a dash plus b dash omega, where a dash and b dash are integers. Now we'll multiply them, we'll get a plus b omega and then a dash plus b dash omega. It'll be a dash b dash omega square plus a dash plus b dash omega. Now we know that omega square is minus 1 minus omega. So we can write this as a dash plus b dash minus 1 minus omega and then plus ab dash plus b dash omega. So we can rewrite this as a dash minus b dash and then plus minus b dash plus ab dash plus a dash b omega. Now again this is an integer and this expression is also an integer. So again it is of the form a plus b omega, where these two numbers are integer. That means this number again, it belongs to S2. So S2 is also multiplicatively closed. So answer to this question is both S1 and S2 are multiplicatively closed, and that's your option D. Now here the question is, when the product of four consecutive odd positive integers is divided by 5, then set of remainders is. We can write any consecutive odd numbers as 10n plus 1, 10n plus 3, 10n plus 5, 10n plus 7 and 10n plus 9, and then again it'll follow the same sequence, 10n plus 1 plus 1, etc. Now there are two possibilities. One possibility is, out of these four numbers, one of the number is of the form 10n plus 5, which is divisible by 5. So in that case, remainder will always be 0. So if we take four such numbers which include this 10n plus 5, in all such cases, remainder will be simply 0. Now there is this another case if we consider such four numbers which doesn't contain this 10n plus 5. So we can choose such numbers as 10n plus 7 into 10n plus 9, 10n plus 1 plus 1 and then 10n plus 1 plus 3. Now when we divide this product with 5, then its remainder will be the remainder of this constant term, which is 7 into 9 into 1 into 3, which is when divided by 5. So it will be this 189 by 5, and if we divide by 5, we'll always get this remainder as 4. So there are only two remainders possible, either 0 or 4, and that's your option B. Now here the question is, consider the equation x square plus y square equals 2015, where x is greater than or equal to 0 and y is also greater than or equal to 0. How many solutions x and y exist such that both x and y are non-negative integers? So we have x and y which are non-negative integers. Now since x square plus y square, it is an odd number, so one of this number, it must be an odd number and the other number must be an even number. So what we'll do is, we'll say let x is some 2n plus 1 and let y is some 2n. So we can write this as 2n plus 1 whole square plus 2m whole square, and it'll be equal to 2015. So it'll be 4n square plus 4m square plus 4n plus 1, and it'll be equal to 2015. Now if we look at this left hand side is 4n square plus m square plus n plus 1, whereas this right hand side we can write this as 4 into 503 plus 3. So this is of the form 4k plus 1 and this number is of the form 4k dash plus 3. So this left hand side and right hand side modulo 4 gives us two different numbers. That means this equation cannot be true. So this equation has no real roots. So number of such x and y is simply none of these, and that's your option D. Now question number 13 is, let P be a point on the circle x square plus y square minus 9 equals 0. So it is a circle with center at origin and radius 3 units. And this other one, it is a circle with center at 10, 0, and here radius will be simply 2 units. And distance between the two centers, it is 10. Now it says, let P be a point on the circle above x-axis. So there is a point P on this circle, and then there's a point Q on the other circle which lies below x-axis. Now it says, this line joining both P and Q, it is tangent to both the circles. We need to find length of this PQ. Now this PQ is nothing but transverse common tangent, and we know that length of transverse common tangent is simply under root of d square minus r1 plus r2 whole square. Now in this case d square will be simply 10 square, that is 100, minus r1 plus r2. r1 plus r2 is 5, 5 square is 25. So this value is simply under root 75, which is 5 root 3. So length of PQ is 5 root 3, and that's your option C. Now here the question is, let S equals x comma y, where x and y are positive integers viewed as a subset of the plane. Now for every point P in S, let dP denote the sum of distances from point P to the point 8, 0 and 0, 12. So we have 2 points. Eight, 0 and 0, 12, and we have to find every point P such that sum of the distances from these 2 points, it is minimum. Now we know that sum of distances of P from these 2 points will be minimum when this P, it lies on this line segment, say AB. So this P, it must lie on this line segment AB. Now equation of this line AB is x by 8 plus y by 12 equals 1. Now we can write this as 3x plus 2y, and it will be equal to 24. Now we just need to find all the integral coordinates on this line segment AB. Now since x and y, they are positive integers, they cannot take the value 0. And since these two numbers, they are even numbers, this 3x, it must also be an even number. So that means x can only take even values. So the possible values of x are 2, 4 and 6. Now if the value of x is 2, then value of y is 9. If x is 4, y is 6. And if x is 6, y is 3. So there are only 3 set of points possible, 2, 9, 4, 6 and 6, 3. So number of such points is 3, and that's your option C. Now question number 15 is, let ABC be angles of a triangle. Suppose that 10A and 10B are the roots of this equation. Then the value of cos square C minus 8 cos C sin C plus 5 sin square C equals what? Now we know that if 10A and 10B are roots of this equation, then sum of roots, which is 10A plus 10B, will be 8, and product of roots, which is 10A into 10B, will be simply 5. Now from here we can write 10A plus B will be 10A plus 10B upon 1 minus 10A 10B. So this value will be simply minus 2. Now 10A plus B is nothing but 10 pi minus C, and 10 pi minus C is minus 2. Now 10 pi minus theta is minus 10 theta. So from here we can write value of 10C is 2. Now we consider a right angle triangle. Then this is 2, this is 1, and this value is under root 5. Now cos square C will be simply 1 by root 5 square minus 8 Now cos C and sin C. So this value will be 1 by root 5 and 2 by root 5 and then plus 5, and sin square C will be simply 4 by 5. So it will be 5 in the denominator and the numerator will be 20 plus 1, 21 minus 16 will be 5. So this value, it is equal to 1, and that's your option B. Now here for this cos C and sin C, we can take plus or minus sign. But then if we change it in terms of sin 2C, we'll get this as 2 tan C upon 1 plus tan square C. We'll end up getting this positive value. That is the reason I've taken both sin and cos as positive expressions. Now question number 16 is, let A be the set containing 10 elements, A1, A2, A10, and B is the set having only 2 elements, 1 and 2. Now it says we need to find number of functions defined from A to B such that sum of FA1 up to FA10, it is an even number. Now this sum, it will be an even number when we have even number of elements mapped to 1 and remaining even number of elements mapped to 2. Now what are the possibilities? Now what we'll do is, we'll make a table of all such possibilities. So here we write number of FAI which are mapped to 1, and here we write number of FAI which are mapped to 2. Now one such way is, when this value is 10, this is 0. Another one is 8, 2, 6, 4, 4, 6, 2, 8 and 0, 10. In all these 6 cases, this summation FAI, it will be an even number. Now how many such functions exist in which all the 10 elements, they are mapped to 1 and none of the element is mapped to 2? This can be done in simply 10C, 10 ways. Now what about this? 8 of these numbers are mapped to 1. Which 8 elements? So here we need to select 8 elements from these 10 elements. So it can be done in 10C, 8 ways. Now the next one in the same way will be 10C6, and the same way it will go all the way up to 10C0. So total number of such functions will be 10C0 plus 10C2 up to 10C10. Now we know that NC0 plus NC2 plus NCn, it is nothing but 2 to the power of n minus 1. So this value will be 2 to the power of 10 minus 1, which is 2 to the power 9, and that is 512, and that's your option B. Now here the function fx is defined as x plus 1 signum x square minus 1. Now signum function, it can only take 3 values, 1, minus 1 and 0, depending on whether this function is greater than 0, less than 0 or equal to 0. Now if we look at x square minus 1, then when the value of x is minus 1 and plus 1, the value of this function is 0. In that case, the value of this signum function will be 0. Now when x is less than minus 1, this value is positive, and when x is greater than 1, again this value is positive. So in that case, this value will be 1, and between minus 1 and plus 1, this value will be minus 1. So we can write this function fx as x plus 1. Now when x is less than minus 1, this value is positive. So we can write this as 1 when x is less than minus 1. Now between minus 1 and plus 1, the graph of the function lies below y-axis. So this signum function will be minus 1. So we can write this as minus x plus 1, and when x is greater than 1, in that case, the signum function is again 1. So this value will be x plus 1. Now at minus 1 and 1, value of this function is 0. So signum function will take the value 0. So here this function will have this value 0. Now what we'll do is, we'll draw the graph of fx. Now when x is less than minus 1, so at minus 1 this value will be 0. At minus 2 this value will be minus 1. So we'll have this straight line. So this is x plus 1. At minus 1 this value is 0. Now here also this value is 0. And at 1 this value is minus 2. Now value at 1 is 0. At 1 positive, this value is 2. So that is the graph of fx. Now this graph, it is discontinuous at x equals 1. So the number of discontinuities of this function is only 1. And that's your option D. Now question number 18 is, suppose x is a subset of real numbers and this function is defined from x to x. It is a bijection. That is, it is both 1, 1 and on 2. Satisfying this property, fx is greater than x for all x belongs to x. Then this set x, it cannot be which of the following. Now, out of these 4 given sets, this set of positive integers, it starts from 1 and then it goes all the way up to infinite. So if we define this function f from z positive to z positive such that fx is greater than x, then f1, it will be greater than 1. So it simply means that value of this f1, it will be 2 or greater than 2. In the same way, for any n, this value will be greater than or equal to n. That is, this value is always greater than 1. So when we define this function from z positive to z positive, this function fx, it cannot take the value 1. And if it cannot take the value 1, then its range cannot be z positive. So in that case, this function, it won't be an onto function. So this x, it cannot be the set of positive integers, and that's your option B. Now question number 19 is, the set of real numbers x satisfying this inequality 4x square upon 1 minus under root of 1 plus 2x whole square, and it is less than 2x plus 9. Now if we look at domain of this function, then one of the conditions that we'll have is 1 plus 2x, it should be greater than or equal to 0. That is, the value of x is greater than or equal to 1 by 2. And also this denominator, it should not be 0. That is, value of x, it should not be 0. So we have this condition of domain that value of x is greater than or equal to 1 by 2 and it is unequal to 0. Now we'll try and simplify this expression. Now what we'll do is, we'll write this is 4x square 1 minus under root of 1 plus 2x whole square, and we'll multiply and divide with its conjugate. So we'll write 1 plus under root 1 plus 2x whole square upon 1 plus under root 1 plus 2x whole square, and it will be less than 2x plus 9. Now here it will be 4x square into 1 plus under root of 1 plus 2x whole square, and it will be less than, this is a minus b into a plus b. So it will be a square minus b square. So here 1 and 1 will cancel. So we'll get this as 4x square. So we'll cancel this 4x square with 4x square, and it will be less than 2x plus 9. Now we'll square it. We'll get 1 plus 2x plus 1 plus 2 into under root of 1 plus 2x, and it will be less than 2x plus 9. Now here 2x and 2x will cancel. Now this value will be 7. So we'll get this condition that 2 into under root of 1 plus 2x, and it is less than 7. Now we'll square it. We'll get 1 plus 2x, it is less than 49 by 4. That is, 2x is less than 45 by 4, or value of x is less than 45 by 8. Now if we take all these 3 conditions together, then we'll get this condition that this x, it should be greater than minus 1 by 2, but less than 45 by 8, and it should not be 0. So this x belongs to included minus 1 by 2 to 0, and then union 0 to 45 by 8, and that's your option A. Now question number 20 is, let A, B, C, D, E, F, G, H, I, J be 10-digit number where all the digits are distinct. Now it is given that further A is greater than B is greater than C, and A plus B plus C is 9. Now D, E, F, G, they are consecutive odd numbers, and H, I, J, they are consecutive even numbers. Then we need to find the value of A. Now in this question we have 10 digits. So starting from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now it says D, E, F, and G are consecutive odd numbers. So here we have consecutive odd numbers as 1, 3, 5, 7, and 9. So either D, E, F, G, they could be this 1, 3, 5, 7, or they could be 3, 5, 7, and 9. Now H, I, and J, they are consecutive even numbers. Now consecutive even numbers, it could be either 0, 2, 4 or 2, 4, 6 or 4, 6, and 8. Now we have to choose these three even numbers in such a way that A plus B plus C is 9. From here we can clearly say consecutive 4 odd numbers must be 3, 5, 7, and 9. That is, value of D should be 9, value of E should be 7, value of F should be 5, and value of G should be 3. Reason for that is, if we choose D as 7, so it will be D, E, F, and G, then this 9 will be assigned to either A or B or C. And if it is assigned to A, B, or C, then their sum, it cannot be 9, it will be greater than 9. That means this 9, it cannot be assigned to A, B, C, and since H, I, and J, they are even, it must be assigned to this D, E, F, and G, and since D is the greatest one, odd numbers must be assigned in this fashion, D, E, F, and G. Now once we are done deciding these odd numbers, we need to choose 3 consecutive even numbers, and we have to choose 3 consecutive even numbers such that sum of remaining 3 numbers, it must be 9. So now we are left with 0, 1, 2, 4, 6, and 8, and here we have to take 3 consecutive even numbers H, I, and J. Now one possibility is this is Hij, second possibility is this is Hij, and this third possibility is this 0 and 2, 4, it is H, I, and J. Now we take 8, 6, and 4, this sum, it is unequal to 9, so we'll discard this one. Now what about 2, 4, 6, we get 8 plus 1 plus 0, which is 9. So that means this set 2, 4, and 6, it must be this H, I, and J. So this is J, this is I, and this is your set H. Now we are left with 0, 1, and 8. Now these 3 numbers, they must be A, B, and C. Now since A is the greatest one, so this is A, this is B, and C must be 0. So the value of A must be 8, and that's your option D. Now question number 21 is, let A be A comma B comma C, where A, B, C are prime numbers such that A is less than B is less than C, and A plus B plus C is 30, then number of elements in A is. Now clearly this A, it must be 2, because some of these 3 prime numbers, it is an even number. Now except for 2, all of the primes, they are odd numbers. So if we consider all these 3 numbers as odd numbers, then their sum cannot be 30. So from here we can clearly say value of A, it must be 2. Now if we put A as 2, we'll get B plus C and A be equal to 28. Now we need to identify this pair B and C such that their sum, it must be 28. So what I'll do is, I'll write set of all primes. So this is 3, 5, 7, 11, 13, 17, 19, and 23. Now one such combination possible to get 28 is 5 and 23, and the other combination possible is this 11 and 17. And there is no other way to get this sum B plus C as 28. So number of elements in A is simply 2, and that's your option B. Now question number 22 is, we need to find this integral from -1 to 1 fx dx. Now what we'll do is, we'll write this as -1 to 0 fx dx plus 0 to 1 fx dx. Now we'll put the value of fx. Now when x lies between -1 and 0, sin x is negative. So we'll write this as minus sin x upon x dx, and then plus 0 to 1. In this interval, sin x is positive, so it will be simply sine x upon x dx. Now for this first integral, what we'll do is we'll let x as minus t. So we can write this as 1 to 0. This is minus sine minus t upon minus t. Now dx will be simply minus dt. So here minus and minus will cancel. Here also minus and minus will cancel. Now we can change this limit from a to b to b to a. So we can write this as minus 0 to 1 sine t dt upon t plus 0 to 1 sine x dx upon x. Now in definite integrals, if the function is same and limits are same, the value of integral will be same. So these two integrals, they'll have same value with opposite signs. So here these two integrals, they'll cancel. So value of this integral will be simply 0, and that's your option D. Let f be a differentiable function, and suppose also that f dash x equals to 1 for all x belongs to 0 to 2 and 4 to 6. Which of the following is always true? Now we are given that f dash x equals 1. Now if we'll integrate this function, we get fx equals x plus c, which is a straight line. But in this case, for this function, we are given two disconnected sets. It may have one definition in 0 to 2 and it may have another definition in 4 to 6. So this function can be defined as fx equals x plus c1 when x belongs to 0 to 2, and we can define this function fx as x plus c2 when x belongs to 4 to 6, and it is possible that we may have c1 unequal to c2. Now clearly option 1, it is incorrect. Fx is equal to x for all x in the domain. Second one is f is 1 1. Now for this question, it is possible to choose values of c1 and c2 so that this function, it is actually a many-one function. So this function is not 1 1. In the same way, for different values of c1 and c2, this function, it may not always be an increasing function. But what we do know is when x lies between 4 to 6, this is the definition that we are going to use. So if we look at f 5.5 minus f 4.5, it'll be 5.5 plus c2 minus 4.5 plus c2. Here c2 will cancel. So this value, it is equal to 1. Now for the second part, which is f 1.5 minus f 0.5, definition is x plus c1. So it will be 1.5 plus c1 minus 0.5 plus c1. Here c1 will cancel. We'll get this value as 1. So whatever may be the value of c1 and c2, this equation f 5.5 minus f 4.5 will always be equal to f 1.5 minus f 0.5. Now here the question is, consider 50 evenly placed points on a circle with center at origin and radius r such that arc length between any two consecutive points is the same. So for this question, we have 50 points lying on a circle. Now in between any two consecutive points, angle will be 2 pi by 50. If we choose any starting point as z0, then next point will be z0 into e to the power iota 2 pi by 50. Next one will be z0 e to the power iota 4 pi by 50, and will continue. So any general point, it can be expressed as e to the power iota 2k pi by 50. Now if we take any two successive points and we find zk plus 1 upon zk, it will be e to the power iota 2 k plus 1 pi by 50 upon e to the power iota 2k pi by 50. Now this value will be e to the power iota 2 pi by 50. Now this ratio, it is independent of k. So this ratio is constant. And when the ratio is constant, the numbers are in GP. So it represents a GP whose common ratio is e to the power iota 2 pi by 50, or we can write this as cos 2 pi by 50 plus iota sine 2 pi by 50, and that's your option C. Now question number 25 is, we are given two complex numbers z and w with unit modulus. Now we can let z as cos theta 1 plus iota sin theta 1, and we can write W as cos theta 2 plus iota sin theta 2. Now we write mod of Z plus W, it will be mod of cos theta 1 plus cos theta 2 plus iota sin theta 1 plus sin theta 2. Now this value will be under root of cos theta 1 plus cos theta 2 whole square plus sin theta 1 plus sin theta 2 whole square. Now we'll square it, we'll get cos square theta plus sin square theta, which will be 1. So we can write this as 2 plus 2 cos theta 1 cos theta 2 plus 2 sin theta 1 sin theta 2. We can write this as under root of 2 plus 2 into cos theta 1 minus theta 2. In the same way, we can find mod of Z minus W, and there will be cos theta 1 minus cos theta 2 plus iota sin theta 1 minus sin theta 2, and it will be under root of 2 minus 2 cos theta 1 minus theta 2. Now value of this cos theta 1 minus theta 2, it can be either greater than 0 or less than 0. If we take this first case, when value of cos theta 1 minus theta 2, it is greater than or equal to 0. In this case, this mod of Z plus W, it will be greater than or equal to root 2, and mod of Z minus W will be less than or equal to root 2. And in the second case, if cos theta 1 minus theta 2 is less than or equal to 0, in that case, this value, it will be less than root 2. So we can write mod of Z plus W will be less than or equal to root 2, and now here root 2 minus and then cos is also minus. So this value, mod of Z minus W, now will be greater than or equal to root 2. In any case, one of them will be root 2 or greater than root 2. So mod of Z plus W or mod of Z minus W is greater than or equal to root 2. That's your option C. Now question number 26 is number of points in the region x square plus y square less than or equal to 4 satisfying 10 to the power 4x plus cot to the power 4x plus 1, and it is equal to 3 sine square y. Now if we look at 10 to the power 4x plus cot to the power 4x, their arithmetic mean is always greater than or equal to their geometric mean. So we can write 10 to the power 4x plus cot to the power 4x, it is greater than or equal to 2. And if we add 1 to it, then we can say this left hand side, it is always greater than or equal to 3. Now we look at this right hand side, which is 3 sine square y. Maximum value of sine square y is 1. So this is always less than or equal to 3. So left hand side is 3 or greater than 3. Right hand side is 3 or less than equal to 3. So this equation will have a solution if and only if left hand side is 3 and right hand side is also 3. Now left hand side will be 3 when AM is equal to GM, and AM will be equal to GM when numbers are same. So we can write 10 to the power 4x, it must be equal to cot to the power 4x. So from here we'll get this condition that value of 10x should be plus or minus 1, that is value of x should be plus or minus pi by 4. And if we look at this right hand side, this value will be 3 when sine square y is 1 and sine square y is 1 when the value of y is plus or minus pi by 2. So we have two choices for x and two choices for y. So total number of such points will be simply 4, and that's your option C. Now in question number 27 it says if all the roots of the equation are positive, then the value of a plus b is. Now suppose the roots are alpha 1, alpha 2, alpha 3 and alpha 4. We can write S1, which is alpha 1 plus alpha 2 plus alpha 3 plus alpha 4, and this value will be equal to 8. Now we find arithmetic mean of roots. This arithmetic mean of roots, it will be simply 2. We can also find S4, and S4 will be simply 16, and which is product of all the roots alpha 1, alpha 2, alpha 3 into alpha 4. This is 16. And if we take their geometric mean of all the 4 roots, again it is 2. So here for this question, we have this condition that arithmetic mean is equal to geometric mean. And we know that AM is equal to GM when all the numbers are same. So alpha 1 equals alpha 2 equals alpha 3, and it is equal to alpha 4. So all the roots, they are same and they are equal to 2. Now we need to find the value of A and B. Now A is summation alpha beta. Now how many terms do we have in this cyclic summation? So we have 4 roots. So it will be simply 4C2, and then for each term we'll have this value as 2 into 2. So this value will be 6 into 4, and there will be 24. Now in the same way, we can find the value of B. B is this cyclic summation alpha 1, alpha 2, alpha 3. So it can be done in 4C3 ways, and then it will be simply 2 cube, and we'll have this minus sign. So it will be equal to minus B. So value of B will be minus, and then 4 into 8, and 4 into 8 is minus 32. So the value of A plus B, it will be 24 minus 32, and which is minus 8, and that's your option A. Now question number 28 is, let O denote the origin and A and B denote the points minus 10, 0 and 7, 0. So this point is minus 10, 0, and the other point is 7, 0. This is A and this is B. Now it says, for how many points P on y-axis will the length of all the line segments PA, PO and PB, they'll be positive integers. So we have points on y-axis. So let this point be 0, y. Now it says PA, PO and PB, they must be positive integers. So that means mod of y, it should be z positive. Now what's PA? PA is under root of 10 square plus y square, and PB is under root of 7 square plus y square, and all these 3 lengths, they must be positive numbers. Now we need to find how many such y's exist. Now we'll take this as m, and we'll take this as n. So we can write y square as m square minus 10 square, and from this second we can write y square as n square minus 7 square. Now we'll equate them, we'll get m square minus n square, and it'll be 10 square minus 7 square. So we can write this as m plus n into m minus n, and this value, it will be 10 plus 7 and 10 minus 7. So it will be 17 into 3, which is 51. Now we can have 2 separate cases. Case 1, when m plus n is 17 and m minus n is 3. Now we'll add them. We'll get m as 10 and n as 7. But in this case, we'll get y as 0. But then it said it must be a positive integer. So that means we are not going to consider this case. Now we'll have the second case when m plus n is 51 and m minus n is 1. Now we'll add them, we'll get 2m equals 52. So the value of m, it will be 26, and value of n will be 25. So we'll have m and n as 26 and 25. Now we'll put the value of m or n, we'll get the value of y as 24. So y can take the value plus or minus 24. So there will be 2 such points, 0, 24 and 0, minus 24, such that PA, PO and PB, they are positive integers. So answer to this question is option C. And question number 29, it says, this gx function is defined as this integral from minus x cube to plus x cube ft dt, where ft is greater than 1 for all real t. Then we need to find which of the following option is correct. Now we are given this function gx as this integral from minus x cube to plus x cube ft dt. Now we can find g dash x, and g dash x will be fx cube into 3x square and then minus f minus x cube into minus 3x square. Now here we can take 3x square common. We'll get fx cube plus f minus x cube. Now for this function f, it is always greater than or equal to 1. So this value, it is always greater than or equal to 2, and 3x square is always greater than or equal to 0. So that means this function gx, it is strictly increasing function. Now if we consider g minus infinite, this value will be infinite minus infinite ft dt, and g infinite will be from minus infinite to plus infinite ft dt. Now since it is strictly increasing function, this value it must be negative and this value it must be positive. And this integral from minus infinite to infinite fx dx, it approaches infinite as ft is a positive function. So this gx, it takes value from minus infinite to plus infinite and it is strictly increasing. So if we consider this condition gx equals c, then if we draw a line at y equals c, this line, it will intersect the curve every time at one place. So answer to this question is, for any real number c, the equation gx equals to c has a unique solution, and that's your option B. Now question number 30 says, there are 2n plus 1 real numbers having the property that sum of any n of them is less than sum of remaining n plus 1. Now what we can do is, we can arrange these numbers in any order. Suppose they are arranged as a1, a2, an, an plus 1, an plus 2, and a 2n plus 1. Now it says sum of any n of them is less than sum of remaining n plus 1. So if we take first n numbers, we can write a1 plus a2 plus an, and it will be less than an plus 1 plus an plus 2 up to a 2n plus 1. What if we take n numbers from this n? Then we can write an plus 2 plus an plus 3 plus a 2n plus 1, and it will be less than a1 plus a2 plus an plus an plus 1. Now what we'll do is, we'll add these two inequalities. Now here a1, a2, an will cancel, and here also an plus 2, an plus 3, and a2n plus 1 will cancel. So from here we'll get this condition that 2 times an plus 1, it is greater than 0, that is an plus 1 is greater than 0. Now we have randomly arranged these 2n plus 1 numbers. So any number can be an plus 1th number. That means it must be true for all the numbers. So answer to this question is, all the numbers must be positive, and that's your option A.